Once again, looking at the SAT strategy session first for 8-6. This gives us a system of equations that asks which set of ordered pairs satisfies the system above. And again, usually the SAT and multiple choice questions give you something that you can think your way through. If I were you, I would focus on the part that says x plus y equals 0. Because if x and y equals 0, that means that when you put those two together, they should be opposites. And if you look at 3 plus negative 2, it is not 0. 2 plus negative 2 is, negative 2 plus 2 is, negative 2 plus negative 2 is not 0, that's actually negative 4. And just looking at the answers first, you now have at least an option of you work one out. If it works, then it's the answer. If it doesn't work, then it's not the answer. And so now you simply do 3 times 2 minus 2 times negative 2, which is 6, and then a negative 2 times a negative 2 is plus 4, which does make 10, meaning your answer is B. Now, you could have also done in the old way, the elimination form, where you multiply both sides by 3, got 3x plus 3y equals 0, and 3x minus 2y equals 10. Remembering then that we switch all the signs, getting the answer of those go away, 5y equals negative 10, and dividing by 5, getting the answer of y equals negative 2, which would have then told us it was B because that's the only one that has a negative 2 for y. But other than that, that is another type of question you're going to see on your SAT, actually even on your final, to where you can go ahead and use that. Talking about today, 8.6, yesterday we learned how to completely factor expressions with x squared plus bx plus c. Each of the problems that we saw used the value of a equals 1, which is right there, and they were completed with a low level of work. Today is very similar, but there's just a couple of spots that require a bit more effort. First, I need to make sure you know how to reduce fractions using your calculator. So please make sure your calculator is out and that you're doing this with me so that you don't get caught up on this later. First off, remember that 16 over 20 as a fraction. Actually, you don't need parentheses. It's just 16 divided by 20, and you hit equals. Once you get to 0.8, that is the calculator's version of your answer. But if you want to turn that into a fraction, you hit the math button right here. It's right underneath alpha. You see this button here that says arrow fraction. It means convert it to a fraction, so select it and then hit enter one more time, and you see that it turns it into 4/5 for you. It does the job for you, which is a great thing. B, 80 over 85. Again, all you have to do is type in 80 divided by 85. Hit enter to get it into a decimal. And again, if you want to turn a decimal into a fraction, the way I say it is math, enter, enter. And you see that the actual answer is 16 over 17. Same thing for 126 over 35. You type in 126 divided by 35, get a decimal answer, which is 3.6. If you want to turn that into a fraction, you hit math, enter, enter, which gives us 18 over 5 as a reduced fraction. Alright, this skill should not always require the use of a calculator, but I do that because if you somehow or another get into a fraction that you don't know how to reduce, or you're not really sure if it's right, at least you have a backup plan to get you those. Think of yesterday when we transformed the following fractions into factors. We had x over negative 3, x over 9. We turned that into x minus 3, and x plus 9 because 9 was positive. That was yesterday's work. Today we're just going to have to ensure that we reduce every fraction that we possibly can. So if you consider these two fractions and turn them into factors, first off, 5 and 10 can both be divided by 5, but it actually makes it x over negative 2. This can't be reduced, so your answers are x minus 2 and 5x plus 7. So again, because this can be reduced, we have to reduce it and use that version of the fraction. Because that cannot be reduced, we simply put it in as it is, and this is pretty much all you're going to have to do. Overall, the work is going to be much more difficult, or not going to be much more difficult than what we did yesterday. We just have to be sure to understand the shift that we are making from yesterday's questions, which is simply reducing the fractions and figuring out how to get that top number, and we should be okay. So let's get into some problems so we can figure out how they actually work. Again, this is something where you learn it better through experience than anything else. So let's look and see how this stuff works. Using the strategy we used yesterday, this here multiplies to make 20, adds to make 9. Tree for 20 is 1 and 20, 2 and 10, 4 and 5. Using that idea, the fact that this is a positive 20 means the signs are the same. The fact that this is a positive 9 means everything's positive, and the numbers we are looking for are 4 and 5. The difference today is that we now have a 2x squared, so we kind of ignore the x squared and we simply put 2x over 4 and we put 2x over 5. But that's all we have to do. We take this number and we put it over both of those just like we did yesterday. The difference is 2x over 4 can be reduced to be x over 2 because both of those can be divided by 2, which means that one of my answers is x plus 2. The other answer is 2x plus 5. And again, looking at that long ways, that's 2x squared plus 5 plus 4, which makes 9, and 2 times 5 makes 10, which does give me the answer that I'm looking for. So the only shifts that occur is that you use this number here, ignoring the squared on top, and that you probably have to end up reducing at least one fraction to get your answer. Looking at B, we are looking for numbers that multiply to be negative 36 because that's 4 times negative 9, and add to be 16. And so we look at the tree for 36, which is 1 and 36, 2 and 18, 3 doesn't go, but 4 times 9 and 6 times 6. The fact that this is a negative 36 means the signs are different. The fact that this is a positive 16 means that this side is positive, which means that the small side must be negative. And the ones that make positive 16 would be these here, negative 2 and positive 18, which now means, again, that I take this, ignoring the x squared, or the squared part, and I simply put 4x and 4x on top, with negative 2 and positive 18 on the other one. Reduce every fraction I can. These both can be divided by 2, so that's 2x over negative 1. Reducing this ends up being 2x over 9. And in the end, your answers are 2x minus 1 and 2x plus 9. Okay? So again, the shifts that occur, use that number on top and reduce every fraction that you can reduce. Sometimes it's 1, sometimes it's 2, but it should at least be one fraction you can reduce on this, so make sure you check whenever you do that. Other than that, this one here, we're looking for numbers that multiply to be negative 48 and add to be negative 13. So we make the tree for 48, which if you trust me or if you want to go back and check is fine. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5, nope, 6 times 8. The fact that this is a negative 48 means the signs are different. The fact that this is a negative 13 means this side has to be negative, which means this side has to be positive. And the ones that make negative 13 are positive 3 and negative 16. Once you get those two, you again ignore the squared part and put 8x on top of both fractions, taking these two numbers and putting them on the bottom. This turns into 8x plus 3. That can actually be reduced. 8 and 16 can both be divided by 8, so it's x over negative 2. So it turns into x minus 2 on the other one there. You saw where I was going to make that mistake. Again, you have to make sure that you reduce every fraction. I think it's because I just knew that that wasn't reduced that I almost did that one the way I did. But again, make sure you reduce every fraction as you can. This here, we're looking for numbers that multiply to be 60 and add to be negative 19. 6 times 10, add to make negative 19. Again, 60 is the key number. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Trust me on that. That is your numbers. Or you can go through and go ahead and check it out on your calculator and make the tree. But you've done a lot of those last week, so I don't need you to focus on that for right now. Bottom line is, it's positive 60, so the signs are the same. It's negative 19, which means that every single sign in this needs to be negative. And the ones that make negative 19 are negative 4, negative 15. And so now we take this 6x, ignoring the squared part, and we put 6x over 4, negative 4, and we put 6x over negative 15. These both can be divided by 2, which means that this turns into 3x over negative 2. These both can be divided by 3, which means we get 2x over negative 5. In the end, we end up with 3x minus 2 we end up with 2x minus 5. And that is all that you have to do. Alright. E, these numbers multiply to make negative 10, add to make negative 9. Making the tree for 10 is 1 and 10, 2 and 5. The fact that this is a negative 10 means the signs are different. The fact that this is a negative 9 means the big side is negative, which means the small side is positive. And the ones that make negative 9 is actually the very first list on the list, which is positive 1, negative 10. And so we again ignore the squared, putting 10x on top of both fractions. A 1 on the bottom of the first one, negative 10 on the bottom of the second one. Notice this can be reduced by dividing by 10, which gives us x over negative 1. Because 10 divided by 10 is 1, we don't put it there. 10 divided by 10 is 1, we do put that there. In the end, we end up with 10x plus 1 and x minus 1. Alright. And the last one before we get to the work. Here we're looking for numbers that multiply to be negative 42 and add to be 19. Again, you could use your calculator to verify, but here we're looking at 1 times 42, 2 times 21, 3 times 14, 4 doesn't go, 5 doesn't go, 6 times 7 would end it off. The fact that it makes a negative 42 means the signs are different. The fact that it's a positive 19 means this side is positive and this side is negative. The ones that make 19, negative 2 and positive 21. And so from there what we do is we say, okay, this is a 7, so we put 7x, negative 2 here, positive 21 there. This can be reduced by 7, so you end up with x over 3. And you get 7x minus 2 times x plus 3. So overall, you should notice that the work is pretty much the same. We just have to be careful to reduce the fractions in the end. So please be sure to work hard today, as we will not practice these actual skills anymore. We are moving on to the other tricky problems that are in the unit. Tomorrow is actually a computer day, so you'll get a chance to practice all this stuff tomorrow, as well as catch up on anything else you might be missing. So again, the problems starting tomorrow or starting Thursday are going to force you to think a little differently, so make sure you get practice today and master this today, so that tomorrow when you're working on a computer you can breeze right through it and you'll know how to do it, and then from there we can just wrap up the rest of the unit and get ready for our test in a couple of weeks. Other than that, good luck, and again, let me know if there's anything you need help on. Get the worksheet from me now, and again, the answers are in the back of the room.